Today we're going to study applications of quadratic equations. So we did some review of quadratic equations and some important information of them, how you can get certain pieces of information. And now we're going to use quadratic equations and apply them to word problems and help us to solve those word problems. We're going to do 3 examples together. Here's the first one. The average of 2 real numbers is 41.125 and their product is 1,683. Find the 2 numbers. Okay, so we have 2 numbers that we're trying to solve for. Now, we have to be able to write 2 equations in order for us to solve this. So we're given 2 parts. So the average of those 2 numbers is 41.125, so that will be one equation. And then their product is 1,683, so that will be a separate equation. And then we'll see if we can combine them and be able to solve from there. So let's call x the first number, and we can call y the second number. So the average of 2 real numbers is 41.125. If you have 2 numbers, you're trying to find the average, you would add them and divide by 2. So x plus y divided by 2 is equal to 41.125. That's the first equation. Okay, second equation, their product is 1,683. So simply x times y equals 1683. Now for this problem, we need to somehow combine this. We have 2 equations and 2 variables, but you'll notice that this is not solvable as a linear system of equations because that second equation is not a linear equation, right? It's x times y. Not x plus y or 2x plus 2y or anything like that. So because that second one is not a linear equation, we are not going to be able to do some of the methods that we may have used previously when we were solving a system of linear equations, but we can still use substitution as a way of solving a system of equations, regardless of whether or not they are linear equations. So let's go ahead and do a substitution. We can first take this and get rid of the fraction, so we have fewer things to deal with. Multiply both sides by 2. And then let's get x by itself. Now that we have x by itself, we can substitute that into the second equation, the x times y equals 1683, and we'll have 82.25 minus y times y equals 1683. Okay, now if we are going to multiply this out, we'll end up seeing we have a quadratic, 82.25y minus y squared equals 1683. It's a quadratic, we probably want to move everything over to one side. So I'm moving it so that the y squared is going to be positive. So I'm moving everything over to the right-hand side. So y squared minus 82.25y plus 1683 is going to equal 0. Now this might be hard to try to factor because normally when we factor not with decimals in there. But in this case, because we have this 82.25, we know we'd have to work with decimals. So you might just want to go ahead and use the quadratic formula. So the quadratic formula gives us 82.25 plus or minus the square root of negative 82.25 squared minus 4 times 1 times 1683 all over 2 times 1. Okay, so that comes out to be 82.25 plus or minus the square root of 33.0625 all over 2. And simplifying that even further, we'll end up with 2 answers. That's 44 and 38.25. Now, that's the value for the second number, for y. Now, if y is equal to 44, what is x equal to? Well, you simply plug that into either equation, first or second equation, and you end up finding that 82.25 minus 44 ends up being exactly 38.25. And so if you did the same thing with the second value for y equaling 38.25, then we'd end up with 44. So the 2 numbers, in fact, are just 44 and 38.25. Let's take a look at example 2. A rectangle is twice as wide as it is high. If it has an area of 24.5 square inches, what are its dimensions? Okay, let's try drawing a picture for ourselves. So we have a rectangle. It is twice as wide as it is high. So you can use whatever variables you'd like. Here I'm going to use h for the height. And then we know that the width is twice the height. So that's 2 times h here. If it has an area of 24.5 square inches, what are its dimensions? So if you were to find the area of a rectangle, you would just multiply 2h times h. So 2h times h is equal to 24.5. So that gives us 2h squared over here. And get that h squared by itself first before you take the square root of both sides. So we have 12.25 is equal to h squared, square root of both sides, and that gives us h is equal to plus or minus 3.5. Now, since in this problem we are working with a rectangle, and a rectangle does in fact have measurements, it has a length, it has a width, the measurement cannot be a negative number. So we know h cannot be negative 3.5 here. So h is equal to 3.5. So to find the dimensions, which is what the problem is asking for, we know the height is 3.5, and then we just need to find the width, which is 2 times the height. So 2 times 3.5 is equal to 7. So our rectangle has measurements of 3.5 by 7. All right, example 3. A landscaper wants to put a cement walk of uniform width around a rectangular garden that measures 24 by 40 feet. She has enough cement to cover 660 square feet. How wide should the walk be in order to use all the cement? Let's start by drawing a picture. Here's the garden, and here's the walkway around the garden, and it's a uniform width. Okay, so here in the garden, this is 24 by 40 feet. And that 660 square feet, that's the empty space, the white space inside of that rectangle. So what we need to do is we need to come up with what exactly are the measurements of the entire thing, including the cement walk. Now, since we don't know the exact width of the cement walk, in fact, that's what we're trying to find out, but we do know it's going to be uniform, which means that the width is always going to be some value x or some value w, whatever variable you want to use there. So since we know this is x and this is x, that means that this entire length, including the walk of uniform width, is going to be 40 plus x on either side, so plus 2x. Same thing on the other side. We know the garden is 24, and then we add a uniform width of x on either side, so this is going to be 24 plus 2x. So now we're going to put this all together and try to come up with an equation. Now what we can do is we can say the area of the garden, which is 24 times 40, plus the area that the cement walk is going to take up, which will be exactly 660 square feet, will equal, adding those areas together, will equal the 40 plus 2x times the 24 plus 2x, the area of the entire rectangle, the large rectangle. Okay, so using that, 40 plus 2x times 24 plus 2x, so the area of the entire thing. Subtract out the area of the garden, 24 times 40, and that leaves us with that empty space of 660. And now let's go ahead and multiply this all out. So this ends up being equal to 960 plus 128x plus 4x squared minus 960 equals 660. We see we have a quadratic here, so we go ahead and move everything over to one side, cancel things out. We're left with 4x squared plus 128x minus 660. For this, we can actually divide everything by 4 x squared plus 32x minus 165 equals 0. See if that's factorable. And in this case, it's not, so we're going to resort to using the quadratic formula. Okay, applying the quadratic formula, remember that we will end up with two answers, a plus and minus answer, and we have to determine whether or not both answers are okay. In other words, do both answers give us a positive value for the width of x? So we end up with 4.5 and negative 36.5, and obviously the width of the walk cannot be negative 36 feet, so our answer is going to be 4.5 feet.